I hope you all had a lovely, lovely Diwali at your places. Lovely, safe and healthy Diwali. Now, please, let's get back to the study mode only. Let's get back to our revision and syllabus completion. I can see kids from Nichar have connected. Wonderful. Good afternoon, Nichar. Welcome back to the place classes. Nichar, which topic is going on in your school right now? What chapter are you doing in chemistry? Or are you doing any revision? Two things, please answer. Which chapter you are doing presently in theory classes? And when are your pre-boards starting from? Good evening. Okay, revision is going on. Perfect. When is the pre-board scheduled? When do you have the pre-boards starting? We will also start with revision only in our classes then. I'm sure class 12th has finished syllabus across EMRS centers. Even we will start with revision only then. And we will start with the revision of organic chemistry. Can you tell me when is your pre-board exam? Or are they going on in your schools? Are the pre-boards already going? Okay, December. All right, you have pre-board exams in December. That's wonderful. So you still have one month for revision. Understood. Even today, we'll start with revision only, and we'll start with the revision of organic chemistry. All right. 2 minutes, 2 more minutes, and then we'll start. So class 12 today, since I understand all of you have completed syllabus in your centers, it is mid-November right now, and you have your pre-boards scheduled within the next 15 days. So now the next 15 days are very crucial for you to revise as many times as you can. Try and give multiple number of revisions to each chapter so that you are able to recall it correctly during the exams. ड्यूरिंग एवरी रिविजन, हर रिविजन के टाइम पे आपको कोई ऐसी नई चीज दिमाग में रिटेन रह जाएगी, कोई ऐसी नई चीज दिमाग में बैठ जाएगी जो हो सकता है आपसे एक प्रीवियस रिविजन में रह गई हो. सेकेंडली, सॉल्व एज मेनी नंबर ऑफ प्रीवियस ईयर क्वेश्चंस एज यू कैन. द मोर यू सॉल्व प्रीवियस ईयर क्वेश्चंस, the better your answering skills will be and your scoring chances will be much higher. All right. So all of you must try board level previous year questions. They all are given in NCERT only. Please stick to NCERT for complete practice, not just the back exercises, but also the in-text questions. All right. The questions which are given as examples and which are given in the in-text portion of the NCERT. So today we will be starting with the revision of organic chemistry, first chapter, that is haloalkanes and haloarenes. Okay? All right, shall we start? You are okay with the revision of organic chemistry? We are starting with the revision series in chemistry. And we are beginning with perfect. And we are beginning with the very first chapter of organic chemistry, that is haloalkanes and haloarenes. आइए जल्दी से मेरे साथ सारी reactions revise कर लीजिए, जल्दी जल्दी. RX का मतलब होता है हैलोअल्केन्स और ARX का मतलब होता है हैलोअरीन्स। इनको कॉमन नेम में आप और कैसे जानते हैं? यू ऑल्सो नो देम एज एल्काइल हेलाइड्स और एराइल हेलाइड्स, राइट? Some books they call alkyl or aryl halides. IUPAC name is haloalkanes and haloarenes. Whenever you are doing the organic chapter, जब भी आप organic chemistry का कोई chapter पढ़ने जाएं, तो एक बात ध्यान रखिएगा, हमेशा उसको पढ़ने के 5 स्केलेटन्स होते हैं, 5 फैक्टर्स होते हैं। कोई भी ऑर्गेनिक का चैप्टर लीजिए, उसको आप हमेशा 5 पार्ट्स में डिवाइड कर दीजिए। सबसे पहला पार्ट ए, दैट इज स्ट्रक्चर and nomenclature. Part A will always be structure and nomenclature. Part B will be methods of preparation. Part B will be methods of preparation. Part C will be physical properties. Part C will be physical properties. Then part D of that chapter is chemical properties. Chemical properties. And part E, that is the 5th part, is uses. तो आप कोई भी ऑर्गेनिक का चैप्टर पढ़ेंगे, आप उसको इन्हीं 5 कैटेगरीज में पढ़ेंगे। यू विल स्टार्ट विद द स्ट्रक्चर, नॉमेनक्लेचर, देन यू विल मूव ऑन टू द प्रेपरेशन, देन यू विल मूव ऑन टू फिजिकल प्रॉपर्टीज, chemical properties, and lastly you will study the uses. That ways you will not miss a single reaction and the entire chapter will be very structurally understood by you. Now, if I talk about the structural part of this chapter, कि भाई क्या structures हैं, क्या क्या आपको बातें important ध्यान रखनी है, तो सबसे पहले आप जानते हैं structurally important बातें, you can classify alkyl halides based on positions also, right? अच्छा, कुछ important terms आप जानते हैं, geminal halides क्या होते हैं, geminal and vicinal positions. Quickly exam point of view से geminal positions होती हैं जब एक ही कार्बन पर दोनों हैलाइड प्रेजेंट हो, और विसिनल पोजीशंस होती हैं जब एडजेसेंट कार्बन पर दोनों हैलाइड्स प्रेजेंट हो। 2 इंपॉर्टेंट पोजीशंस, जेमिनल एंड विसिनल। अपार्ट फ्रॉम दैट, डू यू नो द मीनिंग ऑफ एलाइलिक पोजीशंस? एलाइलिक, विनाइलिक एंड बेंजाइलिक पोजीशंस। जल्दी जल्दी आप इन कीवर्ड्स को लिख लीजिए अपने कॉपी में, जिससे कि आपको ध्यान रहे कि आपको इनके एग्जांपल्स बिल्कुल प्रॉपर्ली रिवाइज कर लेने हैं। Another position is allylic, vinylic and benzylic. Allylic position का मतलब होता है पाई बॉन्ड के एडजेसेंट पोजीशन पे लगा हैलोजन, पाई बॉन्ड के अल्फा कार्बन पे लगा हैलोजन। विनाइलिक पोजीशन का मतलब होता है पाई बॉन्डेड कार्बन से लगा हैलोजन, पाई बॉन्डेड कार्बन से लगा हैलोजन। और बेंजाइलिक पोजीशन का मतलब होता है बेंजीन के अल्फा पोजीशन से लगा हैलोजन। बेंजाइलिक का मतलब होता है बेंजीन के अल्फा पोजीशन से लगा हैलोजन। अपार्ट फ्रॉम दैट यू हैव मोनोहैलोजन डेरिवेटिव्स, डाइहैलोजन डेरिवेटिव्स, ट्राइहैलोजन डेरिवेटिव्स, यानी कि कितने नंबर ऑफ हैलोजेंस आपके कंपाउंड में लग रहे हैं। तो स्ट्रक्चरली बातें काफी सिंपल हैं, कुछ भी एज सच डिफिकल्ट नहीं है। डिफिकल्टी कहां से शुरू होती है? डिफिकल्टी शुरू होती है पार्ट बी से, विच इज मेथड्स ऑफ प्रेपरेशन। मेथड्स ऑफ प्रेपरेशन, आइए मेथड्स ऑफ प्रेपरेशन डिस्कस कर लेते हैं जल्दी जल्दी। फ्रॉम अल्कोहल्स, अल्कोहल्स, अल्कोहल से अपन कैसे बनाते हैं? प्रेपरेशन फ्रॉम अल्कोहल्स, देयर आर मल्टीपल मेथड्स, आप जानते हैं। जनरल फॉर्मूला अल्कोहल, अगर मुझे अल्कोहल से जल्दी से बता दो कोई तरीका, अगर मुझे अल्कोहल से अल्काइल हैलाइड तक जाना है, RX तक जाना है, आई कैन यूज PCl5, आई कैन यूज PCl3, आई कैन यूज SOCl2 thionyl chloride, very important. I can use SOCl2, that is thionyl chloride, RCl, and this method is the best method for preparation. SOCl2 is known to be the best method for preparation. Reason being, the byproducts formed in this reaction are both gaseous in nature. The byproducts formed in this reaction are both gaseous in nature. That is why it is easier to separate the alkyl halide from the given byproducts. Hence, this method is the best suited for preparation using alcohols. Then apart from that, what else can you use? Apart from that, you can also use any alkyl halide. You can directly use HX. You can directly use HX in the presence of ZnCl2. In the presence of ZnCl2, this will again give rise to RX, and there will be a lot of byproducts formed. So these many methods can be employed for preparation only from alcohols. For preparation only from alcohols. Please remember these two methods are very important, PCl5 and PCl3. Apart from that, method of preparation from SOCl2 is also very important. All right. So suppose you have a question, please prepare. Please convert this to this. Please convert 2-butanol to 2-chlorobutane. How will you try to do this reaction? Please solve. There is one more method for preparation. There is one more method for preparation. You can use, I'm showing here only. You can use red phosphorus and X2 directly Cl2. एक और method है red phosphorus directly in the presence of given halide will also do the following conversion. All right. So these are the preparation of alkyl halides from different reagents using alcohols. But then very important is the preparation of alkyl halides with hydrocarbons. B. Second, from alkanes. मान लीजिए मुझे कोई भी अल्केन दे दिया है, इसमें अगर मुझे क्लोरीन लगानी है तो सबसे अच्छा तरीका है क्लोरीन इन द प्रेजेंस ऑफ सनलाइट लगाने का. बेटा व्हाट ऑल थिंग्स आर इंपॉर्टेंट इन दिस रिएक्शन? फर्स्ट ऑफ ऑल द इंटरमीडिएट फॉर्म्ड, इस रिएक्शन का इंटरमीडिएट कौन निकल के आता है, बीच में कौन बनता है? फ्री रेडिकल. क्लोरीन रेडिकल इज जनरेटेड बिकॉज यू आर यूजिंग सनलाइट. You can use sunlight also, you can use heat also. Sunlight or heat, they are both radical generators. आपकी रिएक्शन में चार्ज नहीं इंड्यूस करेंगे, they will form radical which is a very reactive and a very unstable reaction intermediate. It will quickly react with the alkane, break the carbon hydrogen bond, and that will give you given alkyl halide. Now we know the stability of alkyl radicals. Stability of radicals. It follows which order? 3 degree, then 2 degree, and then 1 degree. हम जानते हैं always tertiary radicals are most stable, followed by secondary radicals, followed by primary radicals. That is why in this question over here, the alkyl halide formed is a secondary alkyl halide and not a primary alkyl halide, because over here secondary alkyl halide formed will be more stable than the given primary alkyl halide. All right, let's do one more question. Please find please solve this Cl2 in the presence of H nu. Cl2 in the presence of H nu. Identify A. I'm giving 1 minute to solve and then I will discuss. I'm giving you 1 minute to solve and then I will discuss. This is a very simple question. You can see all the methyls are the only ones in which radical can be substituted. Only in the methyl groups the radical can be substituted. Central carbon, quaternary carbon does not have any hydrogen. That is why only, suppose if you have to add only 1 mole monohalogenation, then the only possible product of monohalogenation is substituting chlorine at any methyl carbon. Substituting chlorine at any methyl center. No other product is possible. Okay, if you want to do dihalogenation, maybe then more than one product is possible. But for monohalogenation, only one product will be formed. Wherever hydrogen is removed, chlorine will come and get attached. Important thing, the intermediate formed is radical, free radical. Then, apart from that, we also study the preparation of alkyl halides using alkenes. Very important, 2 rules you have to remember in this. If you remember Markovnikov's addition and anti-Markovnikov's addition, very important. Please listen carefully. From alkenes, you have C double bond C, and the addition of HX happens. Addition of HX across the alkene center. Very important. This follows two different criteria. One is Markovnikov's and the other is anti-Markovnikov's. Quickly recall for me and tell me what is the intermediate formed in Markovnikov addition. Quickly, jaldi se bata do kisko malum hai. What is the intermediate formed in Markovnikov's rule? In Markovnikov's addition. Jaldi se bata do, who's telling? Jaldi se bata do. Which intermediate is formed in the Markovnikov's addition? I'm sure you have all done this. Not done. Not done. Okay. Okay, don't worry, I'll discuss. Don't worry, I will discuss. Okay, then let's understand the mechanism first of all. What is happening? You have an alkene. Alkene कैसी होती है बेटा? Alkenes are always electron rich, meaning alkenes are behaving like a nucleophile, right? Halogen, अच्छा, okay. आइए भाई मैं समझाती हूँ आपको. Listen to me very carefully. You are using alkenes and you are adding HX to them, to the alkene molecule. What is the nature of my alkene? Alkene के पास extra pi bond present है. Alkene has one extra pi bond, meaning alkene is nucleophilic in nature, electron rich in nature. If it is electron rich, it will obviously first get attached to electrophile. सबसे पहले वो क्या चाहेगी? मैं इलेक्ट्रॉन रिच हूं, मेरे ऊपर कोई इलेक्ट्रोफाइल आके अटैक कर जाए. Where is my electrophile in the reaction? So if you see this HX is actually nothing but H positive and X negative. H positive and X negative. So this HX is telling you that it has one electrophile, which is H positive, and one nucleophile, which is X negative. Now, if the substrate that you are using is electron rich, is nucleophilic in nature, obviously since opposites attract each other, वो सबसे पहले क्या करेगा? अपने ऊपर प्रोटॉन का अटैक करवा देगा. वो सबसे पहले क्या करेगा? प्रोटॉन को एब्स्ट्रैक्ट कर लेगा. Now suppose you have an alkene, suppose you have a symmetrical alkene in which both carbons are attached to same kind of valencies. So any carbon can get bonded to hydrogen, right? First step to addition. Any hydrogen can get bonded. Suppose करिए इस कार्बन ने हाइड्रोजन को एब्स्ट्रैक्ट कर लिया. Now me, carbon number 1. My friend, carbon number 2. Both of us were making a pi bond. One of us broke the pi bond and shared it with hydrogen, right? इस बेचारे कार्बन पर क्या हो गया? Deficiency create हो गई. Earlier it was making a pi bond. Now there is deficiency on the carbon, meaning, remember, intermediate formed in this process is an electrophilic deficient carbon center that is nothing but a carbocation. Intermediate formed in the Markovnikov's addition is a carbocation. Now this carbocation, this is electron deficient, or you can say this is electrophilic. This will now look out for any nucleophilic substrate. अब ये बोलेगा कि भाई मेरे पास कोई न्यूक्लियोफाइल आके अटैक कर जाए, तो हमारे पास डब्बे में न्यूक्लियोफाइल प्रेजेंट है. We already have this X negative which is waiting to attack, and that is how X negative will get bonded. That is how X negative will get attached, or you can say that the alkene will get halogenated. Let's understand with an example. Suppose I have CH2 double bond CH2, and I'm adding HBr. What will be the first step? Since my alkene is electron rich, it will always facilitate, it will always want a proton to attack on it. तो भाई सबसे पहले स्टेप में प्रोटॉन का एब्स्ट्रैक्शन हो जाएगा. दोनों कार्बन सेम है, आप किसी भी कार्बन पर हाइड्रोजन ऐड कर दीजिए. सपोज मैंने फर्स्ट कार्बन पर हाइड्रोजन ऐड कर दिया, As a result of breaking pi bond, second carbon will now become deficient. And to help this deficiency, bromine will come and attack, and that will lead to the formation of alkyl halide. That will lead us to the formation of alkyl halide. Clear so far? Clear? Now what will happen in case the carbon pi bonds are different in nature, are asymmetrical in nature? So suppose I have CH3, CH double bond CH2 plus HBr. CH3, CH3, CH double bond CH2 plus HBr. Now I am underlining two carbons. One is with yellow and one is with pink. One is with yellow and the other one is pink. Okay? Both the carbons can attack on proton, and result of that will be that the remaining carbon will get a positive charge. Suppose if the yellow carbon attacks on proton and makes a bond with proton, then positive charge will be formed on the pink carbon. And if pink wala carbon goes ahead and bonds with the proton, the positive charge will be formed on the yellow carbon. You tell me, what do you think, in which case the positively charged formed carbon will be more stable? Whether positive charge on yellow will be more stable or positive charge on pink will be more stable? Quickly tell me, what do you think? Quickly tell me. Secondary will be more stable. Very good. In Markovnikov's yellow, absolutely correct. Perfect. बिल्कुल, इसका मतलब आप लोगों को याद आ रहा है, पूरा पूरा रिकॉल करते करते आप लोगों को साथ में, you are able to recall with me. If you are doing Markovnikov addition, always carbocation is formed, and we know the order of stability is 3 degree most, then 2 degree, then 1 degree. In this case, this one is a primary carbocation, whereas this one is a secondary carbocation. Very good. Anand Kumar Tripathi also, Nichar also. 2-3 kids from Nichar have answered. Perfectly correct. That means first step after addition of hydrogen, positive charge will be formed here. Now bromine will attack on this carbon, resulting in CH3, CH, Dr, CH3. That means bromine will be now bonded to this carbon. Perfectly correct. Absolutely correct. ये तो बात रही मेरे मार्कोनिकॉव एडिशन की. ये तो बात रही मार्कोनिकॉव एडिशन की. What happens in case of anti-Markovnikov addition? So what happens in the case of an anti-Markovnikov addition? What do you think is the radical formed? Very good. Very good. Pink पे बनेगा. Second case, anti-Markovnikov addition. First of all, anti-Markovnikov addition, how will you recognize? It is done in the presence of a reagent called peroxide. अब वो कोई सा भी peroxide ले सकता है. It can take any kind of peroxide. Peroxides are basically R2O2. It can take hydrogen peroxide also. It can take hydrogen peroxide also. H2O2. It can take benzoyl peroxide also. C6H5O2 whole twice. It can take any kind of peroxide to show this kind of a reaction. What does a peroxide do in this reaction? So a peroxide works as a radical generator. Radical generator. Oh, meaning anti-Markovnikov's addition follows the radical mechanism. Markovnikov follows the carbocation mechanism. Anti-Markovnikov follows the radical mechanism. Let's see how the reaction happens. First of all, what is the reaction happening? I will take any alkene. I will take any alkene. Addition of HBr in the presence of R2O2. First of all, what will happen? If you have asymmetric alkene, bromine or halide will be added to the less substituted carbon. Bromine or halide will be added to the less substituted carbon. Mechanism basically is that, first of all, what will happen? R2O2 will break. Homolytically cleave and you will get radical. This radical will further react with HBr and form these radicals. Br radical. This Br radical will now react with the alkene. This Br radical will now react with the alkene in such a way that the new radical formed on alkene is again more substituted. देखो भाई, in this case, radical is that is why formed on the more substituted carbon. Then you will work it up by giving H radical and you will get the desired product. The gist of this entire discussion is that on alkene, HX can be added in two mechanisms. One is the Markovnikov's rule, which follows the intermediate of carbocation, which says that nucleophile will be added to the more substituted carbon. इनमें न्यूक्लियोफाइल कौन था? X नेगेटिव था. X नेगेटिव उस कार्बन पे जाके लगेगा जो more substituted carbon present होगा, right? Suppose this is my more substituted carbon. And if you have R2O2 written on top of your arrow, means the reaction will go via anti-Markovnikov's addition, which says that nucleophile will be added to the less substituted carbon. These are completely opposite. In first case, in an asymmetric alkene, this alkene must be asymmetric. In an asymmetric alkene, there are two rules important, Markovnikov's and anti-Markovnikov's. Markovnikov says more substituted carbon will be having the bromine or nucleophile. Anti-Markovnikov says less substituted carbon should get the nucleophile. Markovnikov follows carbocation as intermediate. Anti-Markovnikov follows free radical as intermediate. So over here, suppose if this is my less substituted carbon, it gets to have halogen. Understood? I hope it was clearly understood. Negative addendum will be added where less no OG hydrogen is present. Be added where less no hydrogen is present. Right. There is one more way of saying Markovnikov's. Either you can say in terms of number of hydrogens, where lesser number of hydrogens are there, their nucleophile will be added. Or you can also say in terms of the carbon substitutions, where the carbon is more substituted, there the nucleophile will be added. It is one and the same thing. If I'm saying this carbon has 2R and 1H, means it has less H or it is more substituted. So you can use either definition. That's absolutely okay. You are absolutely right, Ananta. You can use either definition. Then, apart from that, दे तो रही alkenes की बात. So far, we have discussed the preparation from alcohols, we have discussed the preparation from alkanes, and we have discussed the preparation from alkenes. Now, one more, fourth preparation, that is halide exchange. जल्दी से मुझे बता दो, if I want my given chlorine to get replaced by fluorine, what reagent should I use? what reagent should I use? Quickly, if I recall kariye jaldi se, if I want given chlorine to get replaced by fluorine, which reagent should I use? Quickly help me out. AgF, okay. Any other reagent? AgF is absolutely correct. Any other reagent? I want answers. EMRS Maripadla, good afternoon. Kesla, how are you? Please recall. So basic, and what is the name also of this reaction? So basically this is Schwartz reaction. This is the Schwartz reaction in which you can add AgF, you can add SbF3, you can add COF2, you can add Hg2F2, you can add any fluorine-based reagent. You can add any fluorine-based reagent. These are all commonly called fluorinating agents. These are all commonly known as fluorinating agents. Those agents which have come to provide fluorine in the reaction. Otherwise, adding fluorine directly is not a very feasible reaction. So you have to do halide exchange. आप पहले क्लोरो बनाएंगे फिर उसका आप फ्लोरो बना दीजिए. That is possible. Directly making fluoro from any given alkane is very energetically not feasible. Similarly, tell me if I want to add iodine, if I want to replace my chlorine with iodine, what reagent should I use now? Please tell if I want to add iodine. निचार बिल्कुल सही कह रहा है. NaI, very good. And what reagent in the presence of which solvent? Na. Oh. Just give me 2 minutes. 2 minutes. I'll resolve the audio issue. I think audio is still not functioning. Is it okay now? audible? It will soon go back. Give 2 minutes. Give 2 minutes. I have requested a change of batteries. The audio might create issue once again. Till the time being, I'm okay. Alright. 嗯 The board is not clear. Class 12, the board is not, it's clear now. Okay. And the audio is also now okay. Okay, perfect. I'm writing 2-3 questions. Till then you can solve. Please solve these 2-3 questions. They are based on the preparation only. Okay. These are for your practice and also they are in NCRT, so they will be very helpful for you also. Okay. Then I will ask you. 2-3 questions I'm writing. Okay, Nichar, I will ask, don't worry. Very good, Nichar, you're giving absolutely correct answers. Full revision चल रहा है Nichar का. Okay, these 4 questions, I'm giving 2 minutes. Very good. And then I will ask, okay, I want everybody to participate, not just Nichar. I want answers from Mari Madla also. Very good. And I want answer from Torsindri, Kesla also. And I want answer from Bikrampur also. Ananta Kumar from Bikrampur. Sir, you also. Please help the kids to answer. I will ask you questions, okay? Hmm. 2 more minutes I'm giving and then we will move on. Children, please try these questions. These are all based on the preparations only. We have just discussed the preparations. Okay, let's discuss. First of all, SOCl2 will replace this OH with chlorine, cyclohexane on the cyclohexane molecule. Very good. Which are absolutely correct. And of course, you will have byproducts, SO2 and HCl. Please give complete reactions. You will have byproducts also, SO2 and HCl. Absolutely correct. Second, again, you are, अच्छा मैंने इसमें reagent नहीं डाला. Oh, add Br2. Sorry. I forgot to mention add Br2 in the presence of heat. Now you have, again, remember Br2 in the presence of heat follows radical mechanism. तो इसमें आपको क्या ध्यान देना है? हीट का मतलब रैडिकल बनेगा, और रैडिकल कौन सा स्टेबल बनेगा? ये वाला है प्राइमरी, ये वाला है बेंजाइलिक रैडिकल, अल्फा कार्बन पे बन रहा है. सो ऑब्वियसली रैडिकल फॉर्म्ड ऑन द कार्बन व्हिच इज अटैच्ड टू बेंजीन रिंग इज मोर स्टेबल because of conjugation, right? We have studied this in 11th class. Radical formed on the benzylic system is more stable. Then again, you have alkene and you are adding HIA, but nothing is given on the reagent. Now I am marking two positions, okay? You tell me at which position iodine will get bonded. This is my first position. This is my second position. Quickly tell me in the chat box. Torsindri, please try. Quickly tell me in the chat box on which carbon will iodine get bonded? Carbon number 1 or carbon number 2? Second, very good. Bikrampur, excellent. Very good, Nichar. Nichar, you have a strong competition in Bikrampur. They are on fire today. Second carbon, because you will follow the Markovnikov's rule. Markovnikov's rule says nucleophile gets bonded to the more substituted carbon. Absolutely correct. Okay, what will happen in the fourth question? You have, again, I'm marking two OH. 1 and 2. Which OH will get replaced with HCl? First or second? तोरसिंद्री वेरी गुड, आपने भी सही जवाब दिया पिछले वाले का. विक्रमपुर वेरी गुड. पहले वाले को आप बोलेंगे फिनोलिक ओएच. फिनोलिक ओएच. दूसरा वाला कौन है? नॉर्मल अल्कोहलिक ओएच है. अल्कोहलिक ओएच है नॉर्मल. पहला वाला है फिनोलिक ओएच, दूसरा वाला. वेरी गुड तोरसिंद्री, चार absolutely correct. You are all giving very good answers today. Alcoholic OH, very good. Kesla, Marimadla, beta, everybody is participating. Where are your answers? Phenolic OH is not replaced. Only alcoholic OH is replaced. Please make sure phenolic OH cannot be substituted. Reason being, why can't you substitute phenolic OH? Quickly. Just write one word answer. Why can't we replace the phenolic OH? What is stopping from replacing it? क्या फर्क है phenolic OH को और alcoholic OH को replace करने की दिक्कत आने में? So the only reason that we are facing, the problem that we are facing with phenolic OH is that phenolic OH shows resonance with the benzene ring. And due to this resonance, it shows a double bond character. And due to this double bond character with the benzene ring, it becomes more difficult. Yes, yes, it is resonance stabilized. Due to this resonance, there is a double bond character inside between the OH and benzene ring. And we know that a double bond is more difficult to break than a single bond. What is happening basically is, in case of phenolic OH, you all have studied the resonating structures of phenol. The lone pair of oxygen is in conjugation, resonance with the benzene ring. resulting in the formation of a double bond. And this double bond is difficult to break by the incoming nucleophile. That is why substitution will not occur at the phenolic position. It will only occur at the alcoholic position. Absolutely correct, Vikrampur. Very good. Let's quickly revise the physical properties now. Okay, 1 घंटे 1.5 hour class, and we'll try and revise as much as we can. Okay, let's quickly revise the third part of the chapter, that is physical properties. Physical properties are fairly simple. You only have to probably think of one physical property, that is boiling point. Although there are two physical properties, boiling point and solubility, majorly you will see questions coming from boiling point only. So boiling point is dependent on, first of all, molecular mass or molecular weight of the complex. And if the molecular weight is same, then it is inversely proportional to the branching in the molecule. जितना ज्यादा ब्रांचिंग होगा मॉलिक्यूल में, उतना ज्यादा boiling point will get reduced. That means higher the branching, lower the surface area, lower will be the boiling point. Quickly, on this note, tell me the order of boiling point for this compound, for this question. So I have arranged in the order of increasing boiling point. ठीक है, ये आपका क्वेश्चन है. Let's see who is answering first. You have to arrange them in the order of increasing boiling point. First compound is 1-chlorobutane. I am writing the name, okay, not the structure. You draw the structure. 1-chloropropane, isopropyl chloride. Isopropyl chloride. Quickly. One, arrange them in 1, 2, and 3. You can use 1, 2, and 3 instead of writing the whole name. You can use 1, 2, and 3 instead of writing the whole name. Let me see who gives the answer first. 3, 2, 1. Vikrampur, 3 being most or 3 being least? Increasing order में देना है. ध्यान रखना. 3 being least मतलब one answer I have come from Vikrampur is 3, then 2. Okay, 3 being least. Understood. One answer I have, 3, then 2, then 1. Who else? Nichar, what do we think? Nichar, Kesla, what do we think? Marimadla, do you want to participate? Okay, Nichar is saying 3, 1, 2. Okay, I have two answers from Nichar. One is 3, then 1, then 2. The other is 3 to 1 only, just like Vikrampur. All right. Let me see who else. Okay, more answers from Nichar. They are all saying, okay, Nichar is confused between 3, 1, 1, 2 or 2, 1. Okay. Telangana, answer. Torsindri, Kesla, answer. Let's draw the structure of these molecules. 1-chlorobutane, 1-chloropropane, isopropyl chloride. Isopropyl chloride is this molecule. Iso means when the bonding is at the second methyl, when the bonding is at the second position. Okay. Now you can directly see 1-chlorobutane will have the highest molecular weight. First, let's compare on the basis of molecular weight. First criteria, molecular weight. Molecular weight के हिसाब से obviously 1 will have the highest, followed by second and third में both of them have the same molecular weight because their molecular formula is same. They are actually structural isomers, positional isomers of each other. The only difference in them is of branching. Second molecule has 0 branching. First molecule has 1 branch. More branching, lesser boiling point. That means second will have a higher boiling point than the third one. So this is the correct answer. This will be the correct order. तो Sindri, very good. बिल्कुल सही. This will be the correct order. 3 will have the least boiling point because of branching. These two, and 1 will have the highest because of molecular weight. Very good. Okay, let's see couple of more questions. Let's see 2-3 more questions. Let's revise theory only, then we'll move on to questions, Abhi. Okay? Let's see the chemical reactions of this chapter. They are more important. They are very important, actually. Chemical properties of this chapter, they are very important. And so far, we have not done the preparation of haloarenes, by the way. We have only discussed the preparation of haloalkanes, right? Let's discuss the preparation of arenes also. Preparation of haloarenes. That is also very important from exam point of view. Very important first. You can directly halogenate the benzene in the presence of iron. You can directly halogenate the benzene in the presence of iron. Iron over here, beta, acts like a Lewis acid. Iron over here acts like a Lewis acid. So whenever you are using Lewis acid, halogenation will happen direct on the benzene ring. But if you are using sunlight or heat, then in that case, halogenation will happen on the alkyl group of the benzene ring. See, very important. Please make sure you understand the difference. Suppose I have this compound and I am adding X2. One is I am using heat. One method is I am using heat. Second is I am using Fe. In both the cases, A and B, please tell in which case halogen will get bonded to the carbon attached to benzene. Please tell in which case do you think halogen will get bonded to the carbon attached to the benzene ring. First of all, also tell me what is the name of my benzene compound? What is the name of this benzene compound? Quickly, what do we call this compound? Please tell what is the name of this compound? Toluene, absolutely. Toluene, very good. बिल्कुल सही. Toluene, very good. Now tell me in either A or B, in one case the halogen will get bonded to carbon, that is CH3, and in the other case it might get attached to the benzene ring. Where do you think in which case it will go? A. विचार कर रहा है A. Very good. Very good. A के केस में क्या होगा? साइड चेन हेलोजिनेशन. A के केस में क्या होगा? लगे हुए साइड के चेन पर हेलोजिनेशन हो जाएगा. इसको आप बोलेंगे साइड चेन हेलोजिनेशन. Because you are adding heat. Because you are adding heat or sunlight, the reaction is going via radical mechanism. The reaction is going via radical intermediate. But in case of Lewis acid, there will be direct halogenation. Direct halogenation. And that means in case of iron or AlCl3 or aluminium or any Lewis acid, the product will be formed by directly halogenating the benzene ring. Clear? Clear? So these are ortho and para directive. Yes, bilkul sahi Bikram. CH3 has electron donating effect. That is why incoming electrophile is directed to ortho and para position. So you understand X2 over here will function like an electrophile. Here X2 will function like an electrophile. And here it will function like a radical. These are two different mechanisms. So please don't get confused in the exam when he's given you similar kind of questions, okay? Moving from away, apart from that, second method of preparation from diazonium salts. Diazonium salts N2Cl. N2Cl बनते किससे हैं? First of all, अब अपन पूरी ऑर्गेनिक कर चुके हैं तो हमें पता होना चाहिए अमीन से बनते हैं N2Cl. Quickly, NaNO2HCl. Benzene diazonium chloride, aniline. Yes, Nichar already knew that I was going to ask what is the name of this complex. Very good. I was going to ask you what is the name of the substrate, and Nichar has already answered that it is called aniline. Very good. अच्छा इसी बात पे Nichar, quickly tell me what is the name of this compound? What is the name of this compound? Quickly, this is a slightly side ka question I'm asking, if you allow me. Benzene diazonium halide, yes sir, yes Bikrampur, very good. मारी मटला वेरी गुड आंसर, एनिलीन तो सही है. इसका आंसर, इसका नाम बता दो जल्दी से. बेंजीन के ऊपर मेथॉक्सी. मेथॉक्सी बेंजीन कोई नहीं बोलेगा. आई वांट द कॉमन नेम. प्लीज डोंट से मेथॉक्सी बेंजीन. गिव मी द कॉमन नेम ऑफ दिस कंपाउंड. Slight extra information. This compound, and also you will give me the common name of one more compound after this. Quickly, who knows? Very good. Excellent. We already have a correct answer. Vikrampur, perfect. Anisole. The common name of this complex is known as anisole. इसको साइड में कहीं लास्ट पेज या फर्स्ट पेज पे बना लो. This might help you in one of the exams. Anyhow, you have studied about ethers in the second chapter, alcohol, phenols and ethers. You have studied about that. So you should know the name of this compound, right? Please, if you don't know Nichar, Kesla, Marimadla, Torsindri, please write this down somewhere. This compound is called anisole. इसी बात पे one more complex. One more complex I'm giving. Please tell me the name of this compound. Benzene के ऊपर COCH3. Please tell me the name of this complex. Very good. Very good, Vikrampur. Perfect answers today. Excellent. Excellent. This complex is called acetophenone. Beta, you are in 12th class. You should know the name of these complexes. This complex is called acetophenone. 12th class. Yes, Nichar. Very good. Phenol nahi beta. Phenone. Phenol nahi beta. Acetophenone. You should know the name of these reactions. You should know the names of these complexes. Coming back to the preparation of haloarenes from BDC. Benzene diazonium chloride. So you have benzene diazonium chloride N2Cl. To make given halide, you can follow two steps. You can either add Cu in the presence of HX, Cu in the presence of HX, or you can add CuX in the presence of HX. You can either add Cu in the presence of HX, or you can add CuX in the presence of HX. What are the names of both of these reactions? Both of them will result in the formation of same complex. Same complex will be formed, that is your given haloarene. Only difference is in their names. What is the name of the what is the name of the first reaction? Copper HX is Sandmeer or Gattermann? Copper HX is Sandmeer or Gattermann? गड़बड़ हो जाएगी क्लास 12 संभाल के. Copper HX is Sandmeer or Gattermann? Yes, sir. Nichar, very good. This reaction is Gattermann reaction. Good revision. This reaction is Sandmeyer. If you are using CuX, copper salt, if you are using, then you will use, then the name is Sandmeyer. If you are using elemental copper, pure copper, then the name is Gattermann. All right. There are only 2-3 preparation. Yes, we can directly add Cu2X2 to get alkyl halide. Yes, yes. Absolutely, you can directly add. Bilkul Cu2X2 also, Cu2X2, you can again add to get the given compound. Remember, only the name of that complex will be, name of the reaction will be Sandmeyer reaction. Absolutely. Yes, you do need to acidify the medium a little bit. HCl will be required slightly to acidify the medium. Why? Because benzene diazonium chlorides, they operate in certain acidic conditions and very low temperatures. Always remember, reactions of BDC, they require mildly acidic nature, and they require very low temperature. That is why you must have seen in the NCERT also that in the formation of BDC, what is the range of temperature given? It is often given 0 to 5 degrees Celsius. You must have seen in certain reactions in the book, BDC is always formed at very low temperatures, 0 to 5 degrees Celsius, right? So you can form these kind of complexes also. Now, apart from that, I think there are no more preparations of alkyl halides. Let's quickly jump to the chemical properties of haloalkanes. Those are very important. Let's quickly jump to the chemical properties of haloalkanes. Those are very important. Here, you should be understanding two very important substitution mechanisms, SN1 and SN2. This is part D. Chemical properties. First of all, first we will study the basic substitution reactions. Okay? Basic substitution reactions. I am making a flow chart and then you will answer when I ask. Okay? I am making a flow chart of reactions, but you will only answer when I ask, when I call your name, so that everybody is able to answer. Okay? What will happen if Rx is reacted with? What will happen if Rx is reacted with KOH aqueous, KCN, AgCN? Please just recall them at your end and I will ask you. KNO2, AgNO2, NH3, NH3. So A, B, C, D, E, and F. Again, Rx, what will happen if it reacts with LiAlH4? What will happen if it reacts with LiAlH4? Please quickly solve them and I will ask you. Then what will happen if it reacts with silver salt of carboxylic acid? Silver salt of carboxylic acid and NaSH. NaSH. KOH ka bhai, NaSH. Quickly, you can solve these and then I will ask, okay? F, G, H and I. ठीक है, take 2 minutes quickly and then we'll discuss. इससे आपका बहुत अच्छा रिवीजन हो जाएगा हैलोअल्केन्स का. Take 2 minutes and then we will discuss. Okay, who's telling me what will be A? Who's telling me what will be A? Arre वाह, अरे वाह, excellent. Very good. Bikrampur also and Nichar also. I only asked A. You told me first four directly. Okay. Very good. Kesla, beta, do you also want to answer? Kesla, do you also want to answer? Arre वाह, Nichar. Aye, let's quickly discuss. First will be an alcohol. Absolutely correct. Second will be a cyanide. Very good. RCN. Third will be RNC, isocyanide. Please make sure you mark star so that you are able to revise them. Important. Both of these reactions are important. One is a ionic salt. This is an ionic salt, whereas this compound is a covalent salt. Okay. They are both, that is why their reactivity is different. Ionic salt will give you ions. In this case, you will get Cn negative as the ion, which will replace X and you will get cyanide. But in this case, you will not get ions. Instead, nitrogen with its lone pair will have to attack, and that is why the bonding is from nitrogen end. That is why there are two different products. But in case of KNO2 and in case of AgNO2, the logic is reversed. AgNO2 ke case mein you will get RNO2, but in case of KNO2, you get RONO, nitrite. Then in case of NH3, what do you get? You get amine, RNH2. You will get amine, primary amine, yes. In case of LiAlH4, you will get hydrocarbon. Alkane मिल जाएगा. जल्दी से बता दो, what is LiAlH4? What kind of a reagent is LiAlH4? Quickly, what is the category of reagent it falls in? It is a reducing agent, right? It is a reducing agent. Then in the next case, carboxyl salt of carboxylic acids, you will get ester, RC double bond OR. And then in case of NaSH, what do you get in case of NaSH? Nobody has answered that. NaSH and NaOH will react in the same manner. If NaOH, अच्छा अगर मैंने यहाँ पर NaOH लिख दिया होता तो आप तुरंत कहते थे अल्कोहल बन जाएगा, right? You would have given the answer as alcohol. In this case, you will get RSH. This RSH is known as thioalcohol. This complex is called thioalcohol. Oxygen wala is called alcohol. This one is known as thioalcohol. Yes, Nichar, very good. Yes, RSH बन जाएगा, which is nothing but thioalcohol. बिल्कुल सही. अब ये substitution करवाने के लिए you know that there are two very important mechanisms. You have SN1 mechanism and you have SN2 mechanism. Quickly, let's recall both the mechanisms. These are all substitution reactions. What substitution reactions? These are all nucleophilic substitution reactions. And nucleophilic substitution reactions have two very important mechanisms, SN1 mechanism and SN2 mechanism. Nucleophilic unimolecular and nucleophilic bimolecular. Both of them are very important. Listen, recall them with me very quickly. What happens in case of SN1 mechanism? Suppose you have an alkyl halide. The incoming nucleophile will first of all, what kind of a reaction happens when the reaction goes via SN1? First step is the removal of leaving group. ये X क्या है? ये X मेरा लीविंग ग्रुप है और अगर रिएक्शन को SN1 से जाना होगा तो सबसे पहले स्टेप में क्या होगा? My leaving group will get eliminated and my leaving group always goes with the pair of electron on its head. यानी कि लीविंग ग्रुप हमेशा कैसे जाता है? एनायनिक फॉर्म में जाता है, अपने इलेक्ट्रॉन पेयर को लेके जाता है. एज अ रिजल्ट, कार्बन which is left behind will be remaining with a positive charged form, that is a carbocation form. Now we know what is the hybridization of a carbocation. Quickly, class 12, जल्दी से बता दो, what is the hybridization of carbocation? What is the geometry or hybridization, removal of leaving group, formation of carbon addition of nucleophile? बिल्कुल सही विक्रमपुर, विक्रमपुर बिल्कुल सही कह रहे हो. अब जल्दी से बता दो, what is the hybridization of carbocation? निचार, I'm sure you also know. ये कार्बन अभी फिलहाल कैसा है? sp3 है, टेट्राहेड्रल है. ये कार्बन अभी फिलहाल sp3 और टेट्राहेड्रल है? नहीं. Carbocations are not sp3. No, that carbon is sp3 because it is bonded to 4. Carbocations are sp2 and they are trigonal planar. Carbocations are trigonal planar. That is why in the case of SN1 reaction, when the nucleophile attacks, it can attack from two sides of the plane. Trigonal planar means the structure is lying on the plane of a molecule. It is a planar structure. Now my incoming nucleophile can either attack from above the plane or my incoming nucleophile can attack from below the plane. If my nucleophile attacks from certain plane, so what will happen? अगर मान लो रिएक्शन हो रही है above the plane की, और सपोज करिए मुझे उसी ज्योमेट्री का, उसी कायरलिटी का मॉलिक्यूल मिल जाए जो मैंने स्टार्टिंग में लिया था, and suppose if the reaction is happening from below the plane, I will get the opposite compound. I will get 50% this compound and 50% this compound, meaning both the complexes will be formed. Meaning both the configurations of the molecule will be formed. So if my reactant, if my starting product, for example, is in the R configuration, right? Suppose, for example, if my starting complex is in the R configuration, the product after halogenating, the product after substitution will be both 50% in R configuration and 50% in the S configuration. Meaning, what do we? Yes, Nichar, absolutely correct. Both the isomers are formed, both the enantiomers are formed, both of these enantiomers are in equal concentration, equal probability. That is why you have 50% of R and you have 50% of S. That results in the concept called racemization. Absolutely. बिल्कुल सही रिकॉल कर रहे हैं आप लोग मेरे साथ. Suppose my reactant was in the R configuration. After SN1, the product formed is 50% R and 50% S. This means the total geometry has been racemized. There happens a racemization. Absolutely correct. Now, since first point about SN1, that there happens racemization. Second, why is this 1 over here? Why am I using this 1 over here? How do I know what to put, which number to put, whether it should be 1 or whether it should be 2? I know this because during the substitution reaction, the rate is only proportional to alkyl halide. Nowhere is the rate dependent on the incoming nucleophile. Why? Because the first step was the formation of carbocation, formation of intermediate, which has no role of the incoming nucleophile whatsoever. You can use any nucleophile. आप कोई भी strong nucleophile, weak nucleophile, you can use anything, and even then the carbocation will be formed, leaving group will be left, and the reaction will proceed. That is why the reaction is independent of the concentration of nucleophile. It is only dependent on the concentration of Rx. And this 1 over here tells me that the reaction is unimolecular. This 1 over here tells me that the reaction is unimolecular in nature. Third, the intermediate formed in this reaction. What intermediate is formed? So we have seen carbocation is formed, and whenever there is a carbocation formation, always remember two important things. Always remember two important things whenever you see carbocation. A, order of stability. Stability order is always tertiary is the most stable, then secondary, then primary. We know this. Second, there is always associated a possibility of rearrangement. A possibility of rearrangement, meaning if suppose the carbocation formed is a secondary carbocation, But there is a possibility of rearranging the molecule, shifting hydrogen, shifting methyl, and converting my carbocation to a tertiary carbocation. Then always possibility of rearrangement will happen. All right, let's see this with an example. Let's see this second point with an example. Suppose I have this complex. Suppose I have this complex. And this I am reacting with any nucleophile, order of reactivity, tertiary, then secondary, then primary. Yes, Vikrampur. Very good. Suppose I am adding any nucleophile and I want the reaction to go via SN1. Now the answers are either option A is my nucleophile will get bonded over here, or option B is my nucleophile gets bonded over here. Option C is my nucleophile gets bonded. No nucleophile is bonded, I get an alkene. Suppose, just making some options for you. I'm trying to tell you with an example how possibility of rearrangement is seen in case of carbocations. Okay. Option B, yes. Option B, because we understand that when you are going via SN1, एक कार्बोकटायन, निचार नहीं बेटा, ए नहीं बनेगा, निचार समझिए, निचार बेटा मैं यही एग्जांपल से आपको समझाना चाह रही हूँ. Whenever you see in the reaction that a carbocation is being formed, always remember two important things. First, tertiary is more stable than secondary, then primary. Second, tertiary, then secondary, then primary. Second, if after a rearrangement of the carbocation, you are getting a more stable one, then you will always go with the rearranged product. In this case, when you remove this X, you get a secondary carbocation. In this case, when you eliminate this X, you will get a secondary carbocation. And after this, if you see closely, यहाँ पर एक hydrogen बैठा है, right? This adjacent carbon has a hydrogen. This hydrogen can easily show hydride shift, resulting in the formation of tertiary carbocation. And that tertiary carbocation will be far more stable. कहाँ बनाऊं? Basically, after hydrogen shifts, see, I'll draw it over here. But I hope everybody, they don't want me to like show you a particular screen because I have to delete a couple of them. हाँ, भाई सबके ये एग्जांपल से समझ में आया है possibility of rearrangement. First step is the removal of leaving group and formation of a carbocation. Second step is rearrangement. Then the nucleophile will attack because now it can't be stabilized any further. Understood? Understood? Okay, what will happen? One more question I'm giving. What will happen if suppose I have, okay, leave. तो ये तो बात रही SN1 की. SN1 के बारे में एक और बात. What kind of a solvent is seen? What kind of a solvent is important for SN1 reactions? Conditions of solvent. जल्दी से बता दो. पोलर प्रोटिक, बिल्कुल सही, बिल्कुल सही. पोलर में भी प्रोटिक सॉल्वेंट चाहिए हमें. Polar protic solvent stabilizes SN1 reactions. Why? Because you have charged intermediates formed. You have a charged intermediate formed which will be stabilized by a polar protic solvent. यहाँ तक बात रही SN1 reaction की. We are almost running out of time. Quickly, let's see SN2 reaction also. 2 minutes it will take, okay? Quickly, so that we are able to finish this topic over here. आपका revision हो जाएगा. Quickly, let's see the SN2 reaction also. First of all, what happens in case of an SN2 reaction? Suppose this is my molecule. When the nucleophile attacks, the first step is not removal of proton or leaving group. No, the first step is attack of nucleophile. Firstly, क्या होगा? Nucleophile will attack and it will attack from the opposite side of the leaving group. Suppose I have a tetrahedral molecule. One face of the tetrahedral molecule already has a bulky leaving group present. That means वो face तो hinder हो गया, वो face तो block हो गया. Automatically, the nucleophile will have to attack from the opposite side. The intermediate formed in this case, now see what will happen. So this is the new bond formed between nucleophile and the carbon. This is the new bond formed, and parallelly what is happening? The leaving group is also leaving. The leaving group is also getting eliminated. So this pentavalent state is not stable, is not true. Carbon can never show 5 valencies. That is why this is not an intermediate. This is actually called, very good, Nichar and Vikrampur, excellent. This is actually called transition state. This is not an intermediate, remember, because carbon can never be pentavalent. This is only a transition state, and after that, your X negative leaves, resulting in the attachment of nucleophile. Now, if you are taking R configuration of the reactant, you can see the product formed is properly inverted, 100% inversion. That is why in case of an SN2 reaction, what all points we can remember? First, there happens complete inversion, 100% inversion. Second, since the first step is attack of nucleophile, always a less hindered carbon will be able to facilitate that attack faster. दोबारा सुनिए, क्योंकि फर्स्ट स्टेप न्यूक्लियोफाइल का अटैक करना है, तो जितना कार्बन लेस हिंडर होगा उतना अटैक जल्दी हो पाएगा. That is why in case of SN2 reactions, the order of reactivity of Rx is primary halides are more reactive than secondary than tertiary, right? Primary, then secondary, then tertiary. Reason being steric hindrances. Third, why do I have this 2 written? Because now you can see that my reaction rate is proportional to not just Rx, but in the very first step, the nucleophile is also attacking. Stronger the nucleophile, faster will be the attack. Bigger the nucleophile, faster will be the attack. That means the rate is proportional to both nucleophile as well as Rx. 1 power is key, Net order of the reaction will become 2. That is why we call nucleophilic substitution bimolecular. That is why we call it nucleophilic substitution bimolecular. Third, next, what kind of solvent it favors? What kind of solvent this favors? Quickly. हिंदी में बता दूं? अरे केसला, द स्लॉट इज ऑलमोस्ट ओवर. आप कह रहे हो हिंदी में बता दूं? देखो हो क्या रहा है, क्योंकि आपने आरएक्स, जब आपने एक्स को धक्का देने के लिए न्यूक्लियोफाइल को इंट्रोड्यूस करा, एक्स कब तक धक्का नहीं खाएगा, तब तक बाहर नहीं निकलेगा, जब तक बढ़िया सा न्यूक्लियोफाइल ना डाल दूं. और बढ़िया सा न्यूक्लियोफाइल डालने का मतलब है रेट मेरा न्यूक्लियोफाइल पर भी डिपेंड करेगा. इसीलिए रेट में दोनों बातें आ गई. आरएक्स तो आएगा ही आएगा, साथ के साथ न्यूक्लियोफाइल भी आ गया. नेट क्या हो गया? नेट ऑर्डर हो गया 2. Non-polar solvent, yes. Solvent required is a non-polar solvent. Very good. Absolutely correct. With this, we have revised the very first chapter of haloalkanes and haloarenes. Please, in the free time, today itself, if you can, sit through the NCERT and solve all the questions. आपने अभी ताजा चैप्टर रिवाइज करा है मेरे साथ बैठ के, आप आज ही के आज क्वेश्चंस लगा लीजिए. This chapter will be revised, perfectly revised till the exams, right? Then right before exams, you can make a list of name reactions. इस chapter में जो भी name reactions हैं, Finkelstein, Swartz, Sandmeyer, Gattermann, and Wood's reaction, Fittig reaction. There are 7-8 reactions in this chapter. You can make a list of all the name reactions, and you can keep that list safe with you up till your board exams. So with this, we have revised the very first chapter. In the next class, we will revise the second chapter in the same manner. All right, class 12, let's not waste any more time and meet in the next session. Bye-bye and keep studying, everybody. Take care. Thank you so much for connecting. Vikrampur, Nichar, Tosindri, Kesla, Maza aa gaya, Mari Madla. Thank you so much for connecting. Bye-bye. Take care, everybody. Thank you so much. Thank you. You can all disconnect. Torsindri, thank you so much for connecting. Bye-bye.